Ronald Fisher was a titan of the 20th century, the man who effectively gifted us the language of modern statistics and evolutionary genetics. If you've ever used a p-value or heard of natural selection in a mathematical context, you're walking in his footsteps. Yet, this brilliance had a dark underside. Fisher was a staunch proponent of eugenics, views that remained rigid even as the world moved toward racial equality. This is his paradox: a mind that built the tools for objective truth, yet remained trapped in the web of its own deep-seated prejudices. To understand Fisher, we must view his legacy in two starkly different halves. On one side, we have the scientist, a genius described by Anders Hald as the man who almost single-handedly built the foundations of modern statistical science. His fingerprints are everywhere, from experimental design and population genetics to the very core of neo-Darwinism. On the other sits the ideologue. While his math serves the global good daily, his lifelong championing of eugenics, scientific racism, and even tobacco denial has forced a difficult 21st century reckoning. To understand the brilliance of R.A. Fisher, we must look at his early years. Born in London in 1890, he was quickly recognized as a mathematical prodigy. However, his genius was shaped by a unique hardship: extreme myopia. Forbidden from working under electric light, Fisher was taught to solve complex mathematical problems entirely in his head, without pen or paper. This forced mental visualization gave him a spatial understanding of geometry that few could match, leading his biology teacher at Harrow to famously categorize all his students into just two groups: Fisher and the rest. In 1919, Fisher made a choice that changed science forever. He turned down a prestigious academic post to tackle a massive, messy backlog of crop data at the Rothamsted agricultural station. It was here that he transformed messy data into structured truth by inventing the analysis of variance, ANOVA. He established what we call the holy trinity of experimental design: randomization to eliminate bias, replication to ensure mathematical reliability, and blocking to control for local variation. These principles remain the gold standard for scientific research today. To truly understand why Fisher is called the father of modern statistics, we must look at the concepts he codified that still govern data science today. In 1912, he introduced maximum likelihood, now the universal method for estimating model parameters. He coined the term variance in 1918, giving us a way to isolate causal components from chaotic data. He further developed the F distribution as the backbone of ANOVA and created Fisher information to measure exactly how much knowledge a random variable carries. These are the foundational tools of modern truth. One of the most famous stories in science began with a simple cup of tea. At a Cambridge party, a woman claimed she could tell if milk or tea was poured first. To test this, Fisher designed an experiment with 8 cups, giving birth to the null hypothesis, the baseline assumption that any observed effect is due purely to chance. He formalized the p equals 0.05 threshold for statistical significance, creating a 1 in 20 rule for scientific validation that remains the global standard for proving an effect is real. In 1930, Fisher published The Genetical Theory of Natural Selection, a work Richard Dawkins called the greatest successor to Darwin. Before this, science struggled to reconcile Gregor Mendel's theory of discrete, inherited particles with Charles Darwin's observation of continuous, gradual evolution. Fisher provided the great synthesis, using rigorous mathematics to prove that many discrete genes acting together result in the smooth physical variation we see in nature. This unification effectively built the architectural framework for neo-Darwinism, forever cementing his place in the history of biology. Fisher's mathematical lens extended far into the natural world, illuminating the very mechanics of life. He explained Fisherian runaway, where female preference and male traits co-evolve in a dazzling feedback loop, perfectly illustrated by the peacock's tail. He provided the mathematical proof for Fisher's principle, showing why nature defaults to a 1-to-1 sex ratio. Finally, his work on heterozygote advantage revealed how carrying diverse gene versions can offer a survival edge, maintaining the vital genetic variation that drives all of evolution. Beyond the equations, Fisher was a man of intense, often eccentric convictions. Married at 27, he led a frugal life as a subsistence farmer, even breeding mice in 70 cages within his own home to study genetics, frequently enlisting his 8 children as research assistants. In the ivory tower, he was a combative academic known for fierce, lifelong feuds with rivals like Carl Pearson and Jerzy Neyman. Driven by a powerful geometric intuition that left others struggling to follow his proofs, Fisher remained a stubborn and formidable adversary until the end. Gemini said. We now confront the most troubling aspect of Fisher's legacy, his lifelong devotion to eugenics. Fisher believed that the fall of great civilizations was driven by an inverse relationship between fertility and social class. To counter this, he proposed, quote, family allowances, specifically to encourage the upper classes to have more children. As the Galton professor of eugenics, he didn't just theorize. He actively campaigned for government legislation to support the voluntary sterilization of those deemed feeble-minded. It is the dark thread woven throughout his otherwise brilliant career. In the aftermath of World War II, as the global community moved toward racial equality, Fisher remained a rigid outlier. In 1950, when UNESCO attempted to declare race a social construct with no genetic basis, Fisher was one of the few prominent scientists who refused to sign. He insisted that human groups profoundly differ in their innate capacity for intellectual and emotional development. Perhaps most controversially, he even provided a character reference for Ottmar von Verschuer, a former Nazi geneticist, dismissing Verschuer's deep associations with the Holocaust as misfortune rather than his fault. In the 1950s, Fisher faced a new challenge to his statistical rigor, the link between smoking and lung cancer. He dismissed the mounting evidence as, quote, propaganda, famously weaponizing his own rule that, quote, correlation does not imply causation. Fisher argued that a hidden genetic factor might simultaneously cause the urge to smoke and the development of cancer. However, his objectivity was compromised by a deep dislike of Puritanism, his own pipe-smoking habit, and his role as a paid consultant for tobacco firms. In our final assessment, we see that modern institutions are actively choosing to separate Fisher's mathematical foundations from his memory. University College London renamed its R.A. Fisher Centre to promote an inclusive culture, while Gonville and Caius College removed a commemorative stained glass window. Rothamsted Research similarly renamed a building bearing his name. As historian Joe Kane summarizes, we can respect the brilliant statistical work, even if we cannot respect the man who created it. Fisher's legacy remains a permanent, cautionary paradox of genius. Gemini said. In our final assessment, we find that while the scientific community has largely repudiated the man, it cannot function without his tools. Fisher's math remains an unavoidable legacy, serving as the absolute bedrock for modern technology and AI. In medicine, his principles of randomization are the global gold standard for testing life-saving drugs. In agriculture, his experimental models continue to drive the crop breeding programs that have saved millions from starvation. We are left with a final truth. Modern science is built upon a foundation Fisher designed. Sir Ronald Aylmer Fisher was a monumental figure who founded modern statistics and synthesized genetics with evolution. His journey began as a London math prodigy, leading to his Rothamsted revolution, where he invented ANOVA. From the null hypothesis at UCL to foundational work on blood groups at Cambridge, his scientific brilliance is undeniable. However, his legacy is a, quote, chronology of genius and paradox. He maintained lifelong eugenic beliefs, refused the UNESCO race statement, and even denied the smoking cancer link before his death in Australia.